Welcome all. Now I am going to discuss question number 2 from the grade 2018 paper Electrical Engineering. The question is, in a salient pole synchronous motor, the developed reluctance torque attains the maximum value when the load angle in electrical degrees is. So we need to find the load angle at which the developed reluctance torque. These are all the given options. To know the detailed modeling and derivation of the salient pole synchronous motor, audience can go through the given NPTEL video link. Let us have a brief discussion on the salient pole synchronous motor. Unlike the cylindrical rotor, salient pole is non-uniform shape. So, the leakage reactance is not same all over the surface. For example, this is the direct axis and this is the quadrature axis. The direct axis is along the poles and the quadrature axis is the perpendicular to the poles. The direct axis reactance is represented as XD and the quadrature axis reactance is represented as XQ. So the power consumed by the salient pole synchronous motor is P is equal to V into EF divided by XD into sin delta plus V square by 2 into 1 by XQ minus 1 by XD into sin 2 delta, where delta is the rotor angle, XD is the reactance of the direct axis, XQ is the reactance of the quadrature axis, E is the EMF induced in the motor and V is the terminal voltage of the motor. So, the synchronous power consumed by the salient pole synchronous motor is electromagnetic power plus reluctance power. This is the electromagnetic power and this term is the reluctance power. Let us solve the problem. Given it is what motor? Salient pole synchronous motor, right? Salient pole synchronous motor. And what we need to find? We need to find the delta at which reluctance torque is maximum. Which torque, guys? Reluctance torque. So the formula is P is equal to EF Vt divided by XD into sin delta plus Vt square by 2 into 1 by XD XQ minus 1 by XD into sin 2 delta. We all know that power is equal to 2 pi Nt divided by 60, which means power is directly proportional to the torque. So the power consumed in the motor is directly proportional to the torque generated by the motor. And we are asking us to find the reluctance torque. Reluctance torque means this term should be the maximum. This term when it will be maximum? When sin 2 delta is 1. So sin 2 delta is equal to 1 means 2 delta is equal to 90 degrees. Implies delta is equal to 45 degrees. So the maximum reluctance torque will be developed at delta is equal to 45 degrees. So the load angle in electrical degrees is 45 degrees. Thank you.